Okay. Can you hear me? Okay, so let's just I can see um Alpha X and sports. Well, I don't know who exact. I know who is Alpha FX trader, but I don't know who is sports. But no problem. What we'll be considering is introduction to AI and machine learning, and I felt it was necessary for us to consider this, mm, since that's At least let me give you an overview of what is expected. Can you see the screen I'm sharing? Okay, okay, divine. Oh yeah, yeah. Okay. Can you see the screen I'm sharing? All right, so let me just start. The introduction to AI, that's artificial intelligence and machine learning. We'll also be delving in a little bit into what deep learning is. We want to know what's the difference between the three of them. Firstly, we can see the screen which says, what are we talking about? AI, machine learning, and deep learning. Now, I give a very simple explanation here, which I would like to read then give more insights into it. Okay, Divine is saying it's not very clear. Is that the same thing with you? Alpha FX, I think it's easier calling you that. Okay, give me a moment. Let me try and increase the screen. Okay, Divine, is it now clear? Okay, said it should increase the quality. Okay, so let's continue. The artificial intelligence, the big idea of making computers do things that normally requires human intelligence, and that involves language, recognizing objects, making decisions, or learning. So anything, what that means is that anything that can think, that can speak the language, that can understand the language of humans, can recognize objects, make decisions, or learn is okay. So it's so better now. Okay. So anything that can understand human language, recognize objects, make decisions, or learn. The overall thing is that AI, the concept behind AI is that they should try to do what normally humans used to do. And the way we were able to be sure whether the AI is we are successful in this is it should be getting closer and closer and closer to how human beings can do it. For instance, language is an important thing when it comes to humans. So if a machine is able to understand the language and can recognize objects, can by itself make some decisions without having to be told, and can as well learn by showing it something frequently, that is already in itself an AI. We need to know here that's AI. Then when you come to machine learning, it says machine learning is the way to achieve AI. Instead of writing explicitly step by step instructions of every possibility, machine learning lets computer learn from examples, and those examples are referred to data. Okay, before now, the way it was done is by coding. You just code, and when you are coding, you have to tell the computer step by step that after you do this, you do this. And where the limitation starts coming in is that there are several possibilities, a lot of possibilities that are not captured in a normal way to be. But when it is for machine learning, the concept is you don't tell it step by step. You just show it data and it learns by it. You understand? And the more data you give to the AI, the more it can be able to learn. So the difference between AI and machine learning has to do with the the way to achieve the AI. What I mean is like, for instance, now if I come over and give the machine, because all of these things are all machines, if I give it enough data, that if I give it enough data so that it can learn by it, that process is referred to as machine learning. And even if you check as the name implies, a machine that is learning. Okay, so the process of making the machine learn, the process of making the machine recognize objects is referred to as machine learning. Okay, now it finds pattern in data and uses those patterns to make predictions or decisions. Later on, it might not be in this our introductory class, most likely in the next session, we'll be talking in depth into how to use data for predictions. That we'll still get there, where we'll write some codes, and you'll see how the machine learning model, depending on the model you use, I'll show you I will introduce to you the different models that are available and how you can use them for predictions or for decision making. All of those things are still coming. So machine learning is a subset of AI. Okay, that's the way it is. The bigger body is AI. Inside AI, we have machine learning. And the next one is deep learning. What is deep learning? Deep learning has to do with a specific powerful technique within machine learning. It uses structures inspired by the brain neural network and is especially good at complex tasks like recognizing images or understanding speech. So now in this case, deep learning is also a subset of machine learning. So we are getting more refined as we go down. Artificial intelligence has to do with anything where a machine can learn anything a human can do and can do it, especially when it has to do with repetitive tasks and the rest. But machine learning has we now specify a little bit on the way to achieve this thing. That's machine learning. And thirdly, deep learning. When it comes to deep learning, the major concept is neural networks. The neural network has to do with they took a pattern from how the human brain works. That does not mean that it is patterned according to the human brain, but just the normal concept of how human brain works. And when it comes to neural network, there are three parts involved. We have the input layer, we have the hidden layer, and we have the output layer. There are always three. The input layer is where you feed it with different parameters. The hidden layers is where it processes these parameters, and the output is where it gives you a prediction based on the algorithm that was written in the hidden layers. Don't bother too much about this. We are going to get into details into it in our next class where you'll be hands-on. And I would like to say this ahead. In our next class, it might be nice if you have your laptop with you, or if your phone can also code. I think you can run Google Colab right on phone. I'm not so sure, but I think you should be able to do that. Ehen. So once you can do that, it will help us in the process. I know there are some apps that can run, because when you the language we use in machine learning is Python, and I know there are some apps that can run Python. I'll try and search for them, and I'll try to practice, like work with them to see if they can really do that. If they can, we would take it into consideration. Okay. I hope you understand the difference between AI, machine learning, and deep learning. Is there any question? If there is, we can pop it up in the chat so that I can see it. Okay. So let's move on. If you have any questions, always put it on the chat. I will be able to see it. Now, the next thing there, it says, looking at the analogy, imagine AI is the dream of having a robot chef, right? Machine learning is one way to teach it, letting it watch cooking shows. Now, the cooking show here is the data to learn recipes and techniques. Deep learning might be a specific advanced technique it uses, like learning complex knife skills by analyzing videos of master chefs. Are you seeing how we are refining it little by little by little, until we are more refined in the deep learning? AI is just general. Machine learning is a little bit more specific, and deep learning is well narrowed down. Actually, when we use this analogy to explain it. All right, so let's look at activity one. Think about your daily routine. Where do you encounter technology that might be using AI or machine learning? List 3 to 5 examples. For each, guess what it might be doing. Now, let's look at example one. My phone's spam filter. Guess. It learned from many emails what spam looks like to sort new emails. Example 2 says Netflix recommending shows. The guess is it learned my taste based on what I watched and suggested similar things. Example 3, Google Map predicting traffic. It learned traffic pattern from past data and current conditions. So now I just gave you three examples that is example of either AI or machine learning. Let's look at the filter. The way it works, especially now that AI has been incorporated in all these things, is that it learns from many emails and it was labeled. That's how you, at least in this particular one, it was labeled spam, not spam. So they'll bring a lot of emails. One email, if it is a spam, you will label it spam. Then if it is, you label it not spam. That's how they were labeling it. Then they now train this particular model with this information. And over time, it was able to learn and is able to identify which one is spam and which one is not a spam. And it works like that. If you check most of your emails, you notice that automatically some email just go straight to the spam. So in this particular case here, we have AI working there. The second one is Netflix recommending shows. If you've watched most of this time, even on YouTube can recommend a video to you. Oh, what of this video? Netflix can say, okay, have you tried out this particular series or the rest? And the way they do it is that they would study the videos, or in this case, the series you like a lot. Maybe they will observe that you like a lot of action movies or action series. It will now suggest one according to that and say, okay, maybe you also like this. All of these are all examples of where AI or machine learning is incorporated. Third, Google Map predicting the traffic. Now, there's one key part that is very important whenever you're talking of machine learning, very, very important, and that is a part of data. The more data you're able to feed your model, and when I refer to model is that is what you are trying to create to help in predicting. So the more it can perform better. I hope you're on track. So every one of us, anyone that is online right now, you are going to write down your examples below, or just think about them. Anyone, but I want you to write it down in the comment section. Generate like 3 to 4 examples of where you can see AI at work around you. You can give examples of Siri and all those things. I just want to see what you will say. So just imagine anyone and write it down. Type it in the comment section, in the chat. So I'm still waiting. Oh yes, yes, photo editing. Yes. Any other one? Okay. So Google Voice AI. Okay. What do you mean by Google Voice AI? Where you can talk to it? Okay. I get, yeah, yes. Where you can press the button, like for instance, maybe it's an Android phone, where you press the button and you can talk to it and it will recognize your voice. Yes. Yes. Okay. Any other one? Please, if we can get an extra one, then we can cut AI for creating videos. Awesome. Awesome. All right. While I'm waiting for the answer, let's just keep going. Yes, image generating AI. Okay, that's very nice. Okay, so it's clear that we understood it. So let's keep going. The next part we want to look at is how do computers actually learn, which is very important. because it's true that they learn, but we need to know how they learn. So that we can maximize that and be able to tailor it. So, one, machine learning isn't magic. The core idea is learning patterns from data. That is the cross. If there's anything you are taking from today's class, that is the part of they learn they learn patterns from data. That is the key part. Instead of okay, so the way it is done is instead of programmers writing rules like if the email contains free money, then it is spam. The computer looks at 1,000 of emails already labeled spam or not spam and figures out the pattern itself, like certain words, senders, etc., often correlating with spam. That's how we go. And there are three main styles of learning, and that is where I really want us to look at. So we can see three ones: supervised learning, unsupervised learning, supervised learning, unsupervised learning, and we have reinforced learning. So let's look at them one by one. For supervised learning, meaning that you learning with a teacher or an answer key. How does that one work? The computer gets data that includes both the input and the correct output. So that's how it learns. You give it the input and you tell it, okay, this is the correct one. Let me give an example. Let's say we want the computer to be able to recognize a dog. So the way you do it is that you give it a picture of a dog and you write beside it dog. You give it another picture, let's say a cat, and right beside it, not dog, right? Then you give it a third one, let's say hen, and you write not dog. Then you give it different species of dog. You know there are different types of dogs. You make sure it is robust, because if you give it only one type of dog, the species of a dog, you will observe that when it sees another type of dog, it will not recognize it as a dog. So you have to feed it with enough types of dogs, and in the process, it will be able to learn. It is kind of one where you tell it which one is the right one and which one is the wrong one. That is, or where you give it, when you label your input, your output, it is called supervised learning. The inputs and the correct output. That's the important thing about supervised learning. There is an input and there is an output. And the output is the correct one so that it will know that, oh, okay, this gave this. It is referred to as supervised learning. So anywhere you have an input and you already have an output. Let me give an instance. Let's say, I think some people are into civil engineering. Let's say you carried out an experiment in the lab. You had different parameters, your cement, your fine aggregate, your coarse aggregate, and you mixed everything together and you created a concrete. Then you carried out compressive strength, right? And your compressive strength can be regarded as the output. Do we understand? So it can help it to know that, oh, okay, if I put in these parameters, which are the factors of cement, fine aggregate, and this, I will get this particular compressive strength. So if you give it the compressive strength, it can learn, it can later on predict what the compressive strength will be if you give it the cement, the fine aggregate, and the coarse aggregate. It will be able to predict it after learning a lot. That's supervised learning. Unsupervised learning is learning without labels. The computer gets data and tries to find hidden patterns or structure on its own, like grouping similar items together. So in this case here, you don't tell it anything, you just give it data. And he is the one it's now left for the computer to be able to discover, oh, this pattern, I observe this pattern here, I observe this other pattern in this one. And thereby it learns by itself. The third one is reinforced learning. What is reinforced learning? The concept behind reinforced learning is that it's through trial and error. You know how a child learns? Yes, that's exactly what reinforced learning is. The computer takes actions and gets rewarded or penalized based on the outcome. Let's say, for instance, the child does something, you know it was not right. You know the normal way they usually do is they will beat the child, and the child will pick a learning that, oh, okay, this thing is bad, and will stop doing it. And when he does another one, and you analyze, oh, okay, they like this one. In the process, he will do more of the ones The learner is learning like a child. He will try this one and see that, oh, okay, I was penalized for this, so this I will not go this way. Oh, okay, rewarded for this. So it is a reward system. You create the system, you create it in such a way that you reward it when it gets it right, you penalize it when it doesn't get it right, and thereby it learns through that process. So we have three: supervised learning, unsupervised learning, and reinforced learning. Okay, so let's look at an activity to see how much of it we've learned. All right. Activity two: teach a computer to recognize pictures of cats and dogs. Which learning style seems most appropriate? Supervised, unsupervised, or reinforced? I want us to answer in the chat. Which one would you go for? So, which learning style seems most appropriate? If I want to teach the computer to recognize pictures of cats and dogs, should it be supervised where you label, unsupervised where you leave the computer to be able to figure out patterns by itself, or reinforced learning where you you use the system of reward and punishment? Supervised. Correct. Awesome. Very, very correct. So let's look at this next one. If using that style, what kind of data would you need to give the computer? So that's the next question. If you agree with to be supervised, what kind of data would you need to give the computer? That's a question, and waiting for the answers. Okay. Any anyone? So what data would you give the computer so that it can learn by it? Okay, yes, a picture of a cat and dog and other animals for you to learn to differentiate. Very nice, yes. And well, just to add to it, which is correct, but just to add to it, a picture of several and different cats, different species of cats, different species of dogs, and other animals, so that you can be able to tell the difference. Since it's pattern, it is the concept behind how the computer learns. Yes, image of different types of dogs, yes, and also of cats, pictures of cats and dogs, yes. Okay, awesome, awesome. That's good. Okay, okay. So let's move on to the next one. Learning with labels. So we are going to pick the first one, learning with labels. That's supervised learning. And where we use supervised learning a lot is in classifications. That's not the only place, but it's one of the places. And we want to consider classifications, learning with labels. So let's dive deeper into supervised learning. One common task is classification. This means teaching the computer to assign an item to a specific category or class. Example: is this email spam or not spam? Is this image a cat, dog, or a bird? Is this customer review positive, negative, or neutral? To do this, we need labeled data. Lots of examples where we provide the input, e.g., picture, and the correct category label, cat. The computer learns the visual features associated with each label. By the way, most likely in our next class, either the next one or the third one, you'll be doing this practical where you would download from Google a lot of cats, different species of cats and of dog, and you will train it right there, and we will see how the computer itself will learn by it. As I told you, these are classes will be hands-on. So let's get ready with our laptops. We'll do it ourselves, and you will see how these things are done. And it will be better off if you carry it out yourself. Okay, let's go on. To do this, we need labeled data. Lots of examples where we provide the input, e.g., pictures, and the correct category labels, e.g., cat. The computer learns the visual features associated with each label, right? Okay, now let me just add one more thing. Sometimes you can have a picture where it is not only a cat. Let's say we are looking to identify a cat. Let's say you have a picture that has not only cat but has other objects inside it. So what you do is that you have to create a boundary around the one you're interested, so that the computer can know that, oh, this is the only thing I need to study. So that it will not in the process be studying a cat and also be studying the door that is behind the cat. But we'll get to it when we start doing the practical for this. All right. Next thing is the activity. So let's see what's with this activity. Activity 3, let's build an image classifier using Google Teachable Machine. So for today, we might want to skip this. We will still do it. And the good thing about this Google Teachable Machine is that it does not need code, right? So we'll still do it, maybe not today. We will look into that. So let's skip this, but let's just put an asterisk on it. In our next one, we will really do this. Let's move over to learning with labels. Now, we've looked at learning with labels for classification, and now what we consider is classification of dogs and cats. And we looked at how it is done. The other way you can label is through regression, predicting numbers. Now, the other one was classification. Here is prediction. Let's explain. Another key supervised learning task is regression. Instead of predicting a category like classification, regression predicts a specific numeric value from a continuous range. Example, predicting the price of a house, forecasting tomorrow's temperature, estimating how many minutes a trip will take, guessing a student's test score based on study hours. Regression algorithm looks for trends and relationships. Now, when we are looking at for classification, what it looks out for was patterns. Here, it looks for trends and relationships in the data. For example, they might learn that as the square footage of a house increases, its price tends to increase. That's a relationship. This relationship can often be visualized as a line or curve fitting the data. Key differences: classification predicts a category, regression predicts a number. By category, we mean is it A or B? For a number, how much, how many? Okay, let's look at activity 4. Activity 4, spotting trends and predictions. 1, optional spreadsheet task. Okay, let's look at it. Is this something we can do? How many of us are using a laptop? And how many of us are watching this from our phones? Okay. Alpha X says he has a question. When do we use unsupervised learning? Okay, we will get to it. For the for that unsupervised learning, we'll get to it. We're just considering the supervised learning. It's still down there, right? Okay. We'll answer that one when we get to the unsupervised learning. Okay, please. How many of us are using a phone and how many of us are using a laptop? Okay, so Alpha FX is watching from a phone. Who else is watching from a phone? I just want us to know whether we can practice this particular activity. Okay, so it's like everybody is using their phones. Please, in the next live session we'll be having, it will be nice that as you are watching, you are practicing. I don't just want to be showing you what to do. I want us to be hands on. So please, in our next class, let's come with at least get your laptop somewhere so that you can practice this. All right. So right now, there are two activities we are going to do. Activity activity 4 and activity 3. So let's note it. We'll still come back to it. Okay, let's look at the thought exercise. Situations where predicting a specific number, like regression, will be useful. What information or features will you need to make the prediction? Example, predicting the website visitors tomorrow. Features needed, visitors day of the week, recent marketing campaigns. Now, I write down your examples and just, okay. I want you to put your I wanted to put your answers by the in the comment section while we keep on going. Number 5, learning without labels. Okay, this is where I will discuss about the unsupervised learning. So Alpha FX, I guess this is what you are asking about. So we'll discuss it here. Learning without labels, clustering, finding groups. So the concept here is now for unsupervised learning, the most common type is clustering. We learned that for supervised learning, there are two of them: classification and regression. So classification and regression are supervised learning. For unsupervised learning is clustering. Here we give the computer data without any labels and ask it to find natural groups or clusters based on similarity. Example, grouping similar customers based on their purchasing habits, automatically organizing news articles into topics, identifying different types of stars based on their brightness and temperatures. The computer looks at the features of each data point and groups together the points that are close or similar to each other, while keeping the similar points in different groups. A popular method is k-means, which tries to find k-cluster centers and assigns each data point to the nearest center. Okay. Mm, coming. Can I find? So let's look at the activities. Imagine the dots below represent different plotted based on amount spent, vertical axis, and number of center axis. So now just trying to see if I can get somewhere I can write so that we can it, but let's just try and visualize it for this particular live stream. As I said, in our next one, we would really work more to do it. Okay, it says amount spent, asterisk, asterisk, three asterisks, and the rest of them, number of visits. Okay, this is not well captured. All right, so let's leave it. We cannot be able to do this. Let's move to 6. Now, the major concept when it machine learning is data. Data. We cannot overemphasize this. Most of the models we know about now, whether it comes from OpenAI, whether it's from Google Gemini, whether it's from different models that we know about, all of them, if they tell you the number of data, I think for OpenAI, at some point it's I can't get the specifics, but they were close to a million or billion parameters that it was fed with, and the data were in the billions, I think, at some point. But I don't want to give details until I have my. The point is that the data that was used was very large, and that is why if you try and use some of the models, it's very robust. It's very, very robust. So we have mentioned data a lot. It is the fuel for almost all machine learning. Let's recap key ideas. Features. What do we mean by features? The features here is the input characteristics used for learning, e.g., pixels in an image, words in an email square footage of a house, or cement, fine aggregates, coarse aggregates when you are considering concrete. All of these are referred to as features. Labels. Labels here refers to the correct answers used in supervised learning, e.g. cat, spam, 300,000. It matters. We've heard of garbage in, garbage out. If your data is wrong or irrelevant, your AI model won't perform well. This particular point is key. I remember a time where I was running an analysis. That's a model. One of the things I had to do before starting was to what we call pre-processing. There's a pre-processing part where you work on your data. You remove every incomplete data. You make sure that the format is correct, because if these things are not put in place, the computer will learn wrongly. It will learn the wrong things, and its prediction. And the problem with learning wrongly is that it will predict wrongly. That's where the garbage in, that's the data you gave it, garbage out, the prediction it will give you, or the classification it is going to give you, will be false, and it cannot be trusted. So if you want to get the best result, please always take note of your data. Get correct data. For instance, if it's for classification, you have to ensure that the pictures are not blurry, they are very sharp, high contrast, so that the computer can learn from it effectively well. Bias is a risk. Data often reflects the real world, including its biases. If training data is skewed, mostly show pictures of one type of person, the AI model might learn that bias and perform unfairly or poorly on other groups. This is a major ethical concern. Okay, now for the one, let me give you an example. Let's say you want to train the model or the computer to be able to identify cats and dogs, right? That's what it's after, not just cats, but cats and dog. If you are going to feed it, you have to ensure that you feed it with not just only cats, but the proportion of the cat and dog should be the same. Let's say, for instance, 50-50, so that it will not just learn and know how to do cats very well, and will not be able to learn how to identify dogs very well. And in that process, it will carry a bias where it tends to be able to predict cat better than it can predict dog. So that's why they said we should get say, and it can perform unfairly or poorly in other groups. So the way out is to give it a fair amount of data across all the groups we are interested in. And this very activity 6, we can also do that. Okay, let's move to 7. Project journey simplified. Create an AI or machine learning model usually follows creating an AI or machine learning model usually follows a process, even if it is iterative. You might circle back and repeat processes. Number one, goal. What are you solving? Is it classification problem, or is it regression problem? You have to in it, because the way you go about it, the well, the way you go about it is different for how you go about. If it's for classification, the way you go about it is different. The modules you use is different if it is going to be prediction. Next thing is data, is get relevant data. Is it labeled? Number 3, prepare, clean the data. Number 4, choose model types, classification, regression, or clustering. Let the computer learn from the data. That's what training means. The learning process, when the computer learns from the data, it is referred to as training. You are training the computer to learn from the data. Evaluate, test how well the model performs on new unseen data. Very important. You can call this one evaluate tests. That's what they refer to as tests. I know if you've heard about training and testing. Training is let the computer learn from the data, and evaluating has to do with testing. Test how well the model performs on new unseen data, very important. Lastly, use or refine. Deploy the model if it is good enough, or go back and improve on it if you feel the model is not good enough. All right, this is where we will stop for today. I don't know if there's any questions, so I attend to it. And please, as I said, in our next class, please get a laptop and good internet connection. Any question? If you don't have any, just type I don't have so that we can end today's live. Okay, will it give you accurate answer? So what if the model is giving clear data during the training, okay, and then it is deployed in real time with blurry images? Is it supposed to give the accurate answers, or will it notify you that the images are bad? Okay, now it might not notify you, but that's based on how it is trained. There's a way you write your code. You can write the code to be able to detect when the images, when testing, when the images are not good enough. You can write codes to do that. But if you don't write that code, the only thing you just observe is that it will not be able to predict very well, because the features it learns during training is not the features it's seeing in these blurry images. So it is important that even in your test images, you give it sharp images, train it with sharp images and clear images. Then when you're also going to test it with very good images. If not, it will find it difficult to be able to follow along. I hope I answered that, Alpha FX. All right, so no question, no question. Thank you all for attending today's live um, class. It has been awesome, and I love the feedback I've been getting. So please, in our next one, we'll go hands on, big time, hands on. So let's come with our laptops. You will not regret it. And one more thing, please, if you've not yet subscribed to the channel, please do so. At least let's grow let's grow it. Okay, the PDF. Okay, I will find a way to convert this to a PDF because it's not in a PDF format, but I will do so. I would convert it to a PDF and make it available in the group so that everybody can have access to it at any point in time. Thank you all, and this is where we'll end it.